Upon the installation of an automatic transfer switch, or ATS, and a generator, a local inspector identified several deficiencies. This particular installation is for a residential application and serves as an optional standby system. The existing electrical service is single-phase, rated at 600 amps. 3 conduits run from the meter into the main breaker panel boards located in the upstairs laundry area, where the mains are grouped. During the installation, the installer broke into the conduit outside, specifically the one feeding the panel that the generator would supply during a power outage. A junction box, or J-box, was installed and conduit was run from the J-box to the ATS. The ATS unit has a breaker factory installed within it. The utility power is connected to this breaker. The generator set is connected via whip, and the load side of the ATS feeds the panel board upstairs, which is a relatively simple configuration. The inspector cited several issues, including firstly, the mains are no longer grouped, secondly, the J-box and pipe are sharing both sets of conductors, and thirdly, the panel board in the laundry is now considered a subpanel, requiring the separation of grounds and neutrals. The primary question is whether the breaker within the ATS should be considered a main breaker, considering that the ATS could have been ordered without this breaker. If it is indeed a main breaker, then section 230.72 B of the National Electrical Code, or NEC, comes into play. If it's not considered a main breaker, then the panel board's grounds and neutrals would not need to be separated, and the sharing of conductors within the conduit might not be an issue. Furthermore, when the breaker in the ATS is opened, the generator set starts and transfers power to that panel, which raises the question of whether it can truly be considered a main breaker. The inspector has requested the installation of a 600 amp disconnect and that the panels be treated as subpanels, including the installation of ground conductors to these panels. Addressing the core question of whether the breaker in the ATS should be considered a main breaker, the answer is yes. The breaker within the ATS should be classified as a main breaker for several reasons. Firstly, it provides overcurrent protection for the downstream load. This means it safeguards the electrical components and wiring connected to it from excessive current that could cause damage or create a safety hazard. Secondly, it has the capability to disconnect all ungrounded conductors of the system. This is a critical safety feature that allows for complete isolation of the electrical supply during maintenance, repairs, or emergencies. Thirdly, it meets the requirements outlined in section 230.72 B of the National Electrical Code, NFPA 70. This section specifically addresses overcurrent protection for conductors connected to the supply side of the service disconnecting means. It mandates that such overcurrent protection must be provided by either circuit breakers or fuses. Therefore, the breaker in the ATS fulfills this requirement by acting as the overcurrent protection device for the conductors connected to the utility supply. Regarding the applicability of NFPA 70 section 230.72 B, it's important to note that this section applies to all service conductors, without exception. This includes any conductors that supply an automatic transfer switch. The fact that the ATS is designated as optional or for standby use does not exempt it from compliance with this code requirement. The code makes no distinction between essential and non-essential systems when it comes to service conductor protection. Turning to the classification of the panel board in the laundry area, it is now considered a subpanel. This is because it is being fed from the ATS, which is now acting as the main service disconnecting means. When an ATS is installed and becomes the primary point of connection to the electrical service, any panel boards downstream of it are automatically classified as subpanels. As a result of this reclassification, it is necessary to separate the grounds and neutrals within the panel board, in accordance with section 250.24 of NFPA 70. This separation is essential for preventing neutral currents from flowing on the grounding conductors, which can create safety hazards and interfere with the proper operation of electrical equipment. Addressing the issue of conduit sharing, it is not permissible for the conduit to contain both sets of conductors, that is, the utility conductors and the generator conductors. This practice is a violation of section 300.3 B of NFPA 70, which explicitly prohibits conductors of different electrical systems from occupying the same raceway, cable, or enclosure. The rationale behind this prohibition is to prevent potential hazards such as insulation breakdown, arcing, and the propagation of faults between the different systems. Concerning the additional requirements stipulated by the inspector, the request for a 600 amp disconnect and the installation of ground conductors to the subpanels are both considered reasonable safety measures. The installation of a 600 amp disconnect provides a readily accessible means of completely isolating the electrical system in case of emergencies or maintenance. This disconnect serves as a main shutoff for the entire system and enhances the safety of personnel working on the electrical components. The installation of ground conductors to the subpanels ensures that these panels have a reliable and dedicated ground path. This ground path provides a low impedance route for fault currents to flow back to the source, which facilitates the rapid tripping of overcurrent protection devices and minimizes the risk of electric shock. In conclusion, even though an ATS is often considered an optional standby system, it is crucial to recognize that the conductors connected to it must adhere to the same electrical safety requirements as service conductors. These requirements are in place to protect people and property from electrical hazards. The inspector's citations are indeed valid and reflect a commitment to ensuring a safe and code-compliant installation. It is essential to make the necessary corrections to bring the installation into compliance with the applicable codes and standards. This will not only ensure the safety of the electrical system, but also provide peace of mind knowing that the installation meets the required safety standards. The National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. Compliance with the NEC is essential to ensure the safety of electrical systems and to protect people and property from electrical hazards. When installing an automatic transfer switch, or ATS, it's critical to understand the applicable NEC requirements to ensure a safe and code-compliant installation. Here is a breakdown of some key NEC considerations for ATS installations. Firstly, Article 230 covers services. This article provides requirements for service conductors, overcurrent protection, and disconnecting means. When an ATS is installed, it often becomes part of the service equipment, so compliance with Article 230 is crucial. Secondly, Article 250 covers grounding and bonding. Proper grounding and bonding are essential for electrical safety. Article 250 provides requirements for grounding electrode systems, equipment grounding conductors, and bonding of metal parts. In an ATS installation, it's important to ensure that all metal enclosures and equipment are properly grounded and bonded. Thirdly, Article 300 covers wiring methods. This article provides general requirements for wiring methods, including raceways, cables, and conductors. When running conductors to and from the ATS, it's important to follow the requirements of Article 300 to ensure that the wiring is installed safely and correctly. Fourthly, Article 408 covers panel boards. If the ATS feeds a panel board, the panel board must comply with the requirements of Article 408. This includes requirements for overcurrent protection, conductor termination, and identification of circuits. Fifthly, Article 700 covers emergency systems. If the ATS is part of an emergency system, it must comply with the requirements of Article 700. This includes requirements for reliability, capacity, and testing. Sixthly, Article 701 covers legally required standby systems. If the ATS is part of a legally required standby system, it must comply with the requirements of Article 701. This includes requirements for reliability, capacity, and testing. Seventhly, Article 702 covers optional standby systems. If the ATS is part of an optional standby system, it must comply with the requirements of Article 702. While the requirements for optional standby systems are less stringent than those for emergency and legally required standby systems, it's still important to follow the applicable requirements to ensure a safe and reliable installation. In addition to these specific articles, there are other general requirements in the NEC that may apply to ATS installations. These include requirements for conductor ampacity, overcurrent protection, and equipment listing and labeling. It's important to consult the NEC and any applicable local codes and standards to ensure that the ATS installation complies with all requirements. When installing an ATS, it's important to consider the type of system it will be used in. The NEC distinguishes between three types of standby systems. Firstly, emergency systems. Secondly, legally required standby systems. And thirdly, optional standby systems. Emergency systems are intended to provide power to essential loads during a power outage, such as lighting, fire pumps, and life safety systems. Legally required standby systems are required by law or local regulations to provide power to specific loads, such as elevators and communication systems. Optional standby systems are not required by law, but are installed to provide convenience or business continuity during a power outage. The requirements for each type of standby system vary, so it's important to understand which type of system the ATS will be used in to ensure compliance with the applicable NEC requirements. When selecting an ATS, it's important to choose a unit that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or UL. Listing and labeling indicate that the ATS has been tested and meets applicable safety standards. It's also important to choose an ATS that is properly sized for the load it will be serving. The ATS must be able to carry the full load current of the connected equipment without overheating. When installing an ATS, it's important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide detailed information on how to install the ATS correctly and safely. It's also important to use qualified personnel to install the ATS. Electrical work should only be performed by licensed electricians or other qualified individuals who have the knowledge and experience to install the equipment safely and correctly. Once the ATS is installed, it's important to test it regularly to ensure that it is functioning properly. Regular testing will help to identify any potential problems before they cause a power outage. Testing should be performed in accordance with the manufacturer's instructions and any applicable codes and standards. Proper maintenance is also essential to ensure the long-term reliability of the ATS. Regular maintenance should include inspecting the ATS for any signs of damage or wear, cleaning the ATS, and lubricating any moving parts. The maintenance should be performed in accordance with the manufacturer's instructions. Now let's talk about the neutral and ground separation in subpanels. When a panel board is fed from an ATS, it is typically considered a subpanel. In a subpanel, the neutral and ground conductors must be kept separate. This means that the neutral conductors should not be bonded to the panel board enclosure or to the grounding conductors. The reason for this separation is to prevent neutral currents from flowing on the grounding conductors. Neutral currents can create safety hazards and interfere with the proper operation of electrical equipment. To ensure proper separation of neutral and ground conductors in this subpanel, the following steps should be taken. Firstly, install a separate grounding bar in the panel board. Secondly, connect all grounding conductors to the grounding bar. And thirdly, connect all neutral conductors to the neutral bar and do not bond the neutral bar to the panel board enclosure. Another area to consider is conductor ampacity and overcurrent protection. The conductors used to connect the ATS to the electrical system must be sized correctly for the load they will be serving. The conductor ampacity must be equal to or greater than the load current. The conductors must also be protected by overcurrent protection devices such as circuit breakers or fuses. The overcurrent protection devices must be sized to protect the conductors from overloads and short circuits. When sizing conductors and overcurrent protection devices, it's important to consult the NEC and any applicable local codes and standards. Conduit fill is another important consideration. The NEC limits the number of conductors that can be installed in a conduit. This limit is known as the conduit fill. The conduit fill is expressed as a percentage of the conduit's cross-sectional area. The NEC provides tables that specify the maximum allowable conduit fill for different types of conductors and conduits. When installing conductors in a conduit, it's important to ensure that the conduit fill does not exceed the maximum allowable limit. Exceeding the conduit fill can cause the conductors to overheat and can create a safety hazard. Disconnecting means are a crucial safety feature. The NEC requires that all electrical systems have a disconnecting means that can be used to energize the system for maintenance or repair. The disconnecting means must be readily accessible and must be clearly labeled. In an ATS installation, the disconnecting means is typically a circuit breaker or a switch. The disconnecting means must be sized to interrupt the full load current of the connected equipment. Grounding electrode systems are vital for safety. The NEC requires that all electrical systems have a grounding electrode system that is connected to the earth. The grounding electrode system provides a low impedance path for fault currents to flow back to the source. This helps to protect people and property from electrical shock and fire hazards. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. Equipment grounding conductors are another safety component. The NEC requires that all metal enclosures and equipment be connected to an equipment grounding conductor. The equipment grounding conductor provides a low impedance path for fault currents to flow back to the source. This helps to protect people and property from electrical shock and fire hazards. The equipment grounding conductor is typically a wire or a metal raceway. Bonding of metal parts is also essential for safety. The NEC requires that all metal parts of an electrical system be bonded together. Bonding ensures that all metal parts are at the same electrical potential. This helps to prevent electrical shock hazards. Bonding is typically accomplished by connecting all metal parts with a bonding jumper. Finally, remember to consult local codes and standards. In addition to the NEC, there may be local codes and standards that apply to ATS installations. It's important to consult with the local electrical inspector to determine the applicable requirements. The local electrical inspector can also provide guidance on how to install the ATS safely and correctly.